Hi everyone, in this video we're going to be taking a look at how to build a party game world and the various different components that might be involved in the process. Let's go ahead and get started and take a look at what it is we're actually going to be kind of building throughout this video. So let's go ahead and click play. And you'll see here we can go ahead and run around a traditional MapleStory style map. We can enter through the Coin Rush portal. There's a little bit of a ready system here through the UI. And then here we have a mini game where we can kind of run around the map and collect coins. We have to dodge these various different obstacles that are headed our way. Awesome. And now that the world has finished with the timer for the mini game, we can go ahead and see our coin count and then our best coin count from previous runs. So this time I only got a score of 130, which must have been around 13 coins. And you can see my best coin count, which is 20, which is a score of 200. And then we can return, and then we'll take us back to the minigame world where we can play our various different minigames. The first thing that we're going to talk about is implementing map movement, placing various different tiles for the normal map and the rectile map, creating obstacles, spawning those obstacles, creating score items, building the UI, learning data storage, and then we're going to wrap up the whole project. So let's get started. So now let's talk about teleportation. So teleportation in MapleStory worlds is actually pretty easy for the most part. Let's say we want to get the player from map 01 to map 02. We have a pretty easy way of doing that. So this first method I want to look at is through this portal component. This is something that is available to you by default in MapleStory worlds. You can just go ahead, and then if I didn't already have this, I could just add the component, type portal component, and it'll be right there. So that's our first option. And so you can go ahead and with this portal component, all you have to do is set the different settings here. So the collider is the radius at which you can actually use the portal. So here you can kind of see that green box is the range we're able to actually interact with it. And then this box size here is just, and this box offset are actually just different ways of editing this, but you can also just drag and drop it through this edit thing. And then the most important thing is, well, where is our portal going to teleport us? And there, our portal entity reference. This is the other entity that we are actually teleporting to through the portal. So here, I've actually went ahead and set it up so it is the portal on this other map. So let's go ahead and check it out over here. As you can see, we're being teleported to over here. So let's go back to the first map, click play, and we'll see here, if I press up, it's going to go ahead and teleport us to our destination. So there's one additional way we can kind of teleport the player to different positions and different maps, and that's going to be through our teleport service. So this is something that we can actually do through code ourselves. There's a couple of different functions here, and I really recommend you open this documentation and take a look if you haven't already. This teleport service documentation will show us all the different methods related to teleporting. There's a couple different options here for teleporting multiple players at once by reserving them and then sending that reservation all at once. But for now, we're going to focus on the two most core essential teleportation functions, and that's going to be the teleport to entity path, and there's going to be this teleport to map position. Now, these are very simple. So this teleport to map position, you have your entity that you're teleporting. So in most cases, it's going to be like your player or something. The map position, so this is a vector 3, and this is just going to be, your X and your Y position for where the player is going to teleport to on that map, and then the destination map name. So in this case, it might be map 2, or it might be wherever the name of the map is that you want to teleport the player to. And then there is the teleport to entity. So here we have a target entity. So again, it's going to be the player that we want to teleport, and then the destination entity. So here, this could be like teleporting the player to another player or something along that lines. There's actually a third one, and this is actually the one I use in the example because it's a little bit easier for our portal setup. But this is our target entity to entity path. So here the difference is that this is a entity path versus the actual reference to the entity. So this is going to be a string saying like map2/ and then maybe the parent entity and then the child entity, so whatever that is. So in this case, it's going to be the path to the portal, which we'll see what that looks like in just a second. So if I go back to our world, you'll see here I've created this teleport on press component, and I just said scripts, create component. If this is your first example for coding, I really recommend you check out the Pro series. We're going to be kind of skipping some of the essentials and jumping straight into the implementation for this. So here we see the teleport service and then teleport to entity path. So this is a server function because the teleport service only works on the server. And then here we have an event handler handling a keyboard event. And then I'm just checking to see if the key equals T. I think T is a reasonable button, T for teleport. And then here we see it is calling that function and then sending the local player as kind of our player parameter here. Again, going back to that teleport to entity path, we have the player that we're teleporting. This is a reference to the player entity, and I got that just through the user service of the local player because this is happening on the client. And then here I have a reference to the portal, and I did that. I'm currently on the first map right now, so I can only get references to the first map, but I just did that by going to right-clicking on something and then this copy entity path. So now if I go ahead and press play, and then if I click T, you'll see I teleported straight to that entity. So that's how we build teleportation on MapleStory Worlds. We can do it through that portal, or we can do it through code manually. And then you can also do that reserve stuff, which if you're building a larger scale party game world, I definitely recommend you check that out because teleporting multiple players at once is a very useful skill. So the next thing I want to kind of talk about is the different map modes we have on MapleStory Worlds. So as you can kind of see here, and what we kind of just looked at in the last example was we have the traditional kind of MapleStory side view kind of map, but we also have two other kinds of maps. So here, map 2 is currently a rectile map as well, but what if we made a third map really quick? So here, right clicking, we can create a new map. You can also do this through the map list and you can create your maps through here. But for now, I'm gonna right click and then create a new map. Let's move to that new map really quick. So currently by default, this is still a maple tile map. If I were to kind of just place some tiles down really quickly and then spawn in the player, you would see that this is still, oops, I have to set this spawn position, which I did, but I think it is still clipping through the ground. Let's just give it a little bit of height. There we go. So here you can see I'm still in that kind of side view. There are other different modes we can do though. So if I go ahead and go back to this map and I right click it, you can see I can switch to a rectile map or I can switch to a side view rectile map. This side view rectile map is going to function pretty similarly to what we see right now, just so that you can use some custom tile assets. But for now, I want to show you this rectile map. So let's go to here and you'll see I'm kind of in this brown world right now. Let's go ahead and set a similar background to before. Maybe something, we'll just keep the same background as before for now. But now you'll see that I have this little tile set pop up here. So this doesn't use the traditional MapleStory kind of assets here. This has to be kind of something a little bit more custom. There are some preview preset ones that we can use, but this is not going to look like your traditional MapleStory projects. So here we can actually create a tile set. Here I'm going to use this kind of Hennessy's preset. So we're going to kind of create that and we'll call this sample. And so here when we create that preset, you're going to see we have all these different tiles. And now if I actually click play, you will kind of see what I mean and the difference. So this is no longer going to be a side view kind of project. This is going to be more of this kind of isometric top-down view where we can move left, right, up, and down. We're obviously limited by the bounds that we have here. So this is very useful for a party game world. As you saw from the beginning sequence, it doesn't use that traditional MapleStory worlds kind of thing. It uses this. So let's talk about a couple more key details that you will need to kind of build with this new mode. So let's go back to the first mode really quickly, and then I'll kind of show you how building and that works. So here I can open up the tile editor, and if you're using MapleStory Worlds, I'm sure you've seen this before. We can drag, we can drop, we can select a paint box, we can create multiple at once, we can also delete multiple at once. If we click on the corner here and then we delete, we can actually see that we can create different kind of slants and stuff like that. We also have the ability to kind of create walls here. So if I go up here, you'll see that red line is actually the indicator of the foothold. And then when it's straight up and down like this, that means it'll actually move the player from moving left and right. And then of course we could create custom footholds as well. If that's not something you're familiar with, you can take a look at the documentation for that. But that's kind of how we would build our map on traditional MapleStory World's Maple tile mode. We can also create other layers. So if I want multiple tile sets at once and I want the player to be able to jump between them, I can do that as well. So here I've created a new layer, and you can see here I can actually jump between them. Something that's really important to note if you're coding, the player is on whatever map layer they're currently standing on. So here the player is currently on layer 1, and so their visibility will be rendered as if they're on layer 1. So if like maybe you have objects in front of them on layer 2, that's going to be pretty important here. So we can actually see that really quick. Like if I add an object, there we go. And now we click play. We can see here that now the player is going to teleport back and forth depending on what layer they're standing on. So that's something kind of important to keep in note. But now let's go back to that rectile mode that we talked about, which can be useful for our other style of map. So if I go back to our map 3 here, you will see we can also do the same thing here as well. So what's important is that we can use multiple different tiles on the same layer, but we can only use one tile set per layer. So let's say we have a castle tile set, and then maybe we have a grass tile set. The grass is going to have to go on one layer, and then if I add a new layer, we can go ahead and use a different tile set, and we'll just make a random tile set here. And then we have to use this on a separate layer. So a couple of key important things to note. So let's go ahead and delete this layer because we're not going to use this for now. Is that there are a couple different settings for the tiles here. So if I click on this edit tile button here, you'll see we have the ability to adjust the sprite. So we're just going to change what the tile looks like. We also have the ability to edit the passability of the tile. So for here, let's say I want to make this tile unpassable. So basically the equivalent to a wall. Let's go ahead and, so something that trips me up often, and you'll see I just did that here, is that selecting this and is selecting it for being edited, not for actually being used. So I'm going to exit out of that edit mode really quick, and I'm going to drag this tile here. So here we're going to go back to that tile. We're going to go ahead and select it as unpassable. So now when we click play, you will see here that I can no longer pass through this tile. So that's something that's going to be really useful for setting up your rectile, especially for the party game. We're going to want the borders around the map there. And so that's it for the introduction to kind of the basics for map setup. One other last little detail I would like to note is that your movement component. So if you go to the default player, if you're adjusting like the movement speed and the different kind of aspects of how the player like moves physically, on the default player, there are 3 components here. You have the rigid body component, the kinematic body component, and the side body component. These are for the 3 different map types respectively. So the default maple tile is going to use that rigid body, the rectile is going to use that kinematic body, and the side view is going to use the side view one. So that's something that's really important to keep a note in your head for when you're editing the different settings for the movement. So like here we can see, for example, we can change like the different settings like the shadow, the speed, the jump speed, and all of these work in different ways for different kind of map styles. So again, this is just something that you're going to need to keep in mind as you work on your project. So now let's move into the next topic. So now we're going to talk about how to create the different obstacles that you saw in the sample project for this kind of template. So first, we're going to go ahead and take a look at those 3 obstacles. So here you'll see log 1, log 2, log 3. Now we can't currently see them on the map because they are disabled, but let's go ahead and enable those so we can take a look at them. So here I'm going to look at log 1. And so we're going to kind of go through the different properties of it, and then we're going to really quickly recreate basically an obstacle from scratch. And then we'll keep the same name so that the code functions basically the same. So the first thing that we have is the sprite renderer component. So this is the thing that essentially makes it look the way that it does. So the sprite is just basically the image asset. So let's go to that sprite renderer component. And let's say we didn't really want this spike trap. Let's say we wanted this to be like a falling rock or something of the sort. Here, we could change that sprite to be this. It will change the size of it accordingly, so that's something to keep in mind as well. There's also the hitbox though, which is different from the actual size of the sprite. but we're going to take a look at that in just a second. But for now, we're just focused on the sprite render component. So here we have those different settings. The main one to take away from this is the sprite RUID. And then we can actually kind of find sprites through the new resource manager. So if I go to our AI lab tab and then our resource search, this is the new way to kind of find assets on the platform. So here I'm going to search for a trap. And then if we scroll around, we'll actually see that same asset that we used. Maybe you want to search for something different, but here we can kind of copy that RUID. So let's go ahead and we can kind of see the different information about this resource. Also similar resources. So like here, I'm sure in the original MapleStory game, this was probably used as a combination of different objects. So maybe it had this on the left and this on the right. For now, that's not really super important to us. Here we can see all the different tags and stuff like that. But for now, I just want to copy that RUID and then I want to paste it into here. And then so if I go back to the scene, you'll see it has been added back as this kind of trap. Awesome. So that's how we kind of got the visual set up for this. There's also a couple of other different settings. Maybe you wanted to make it like slightly red or something. This doesn't work the best for trying to change the color perfectly, but maybe you just want it slightly darker or something simple. You can kind of do that through the color setting here. You can flip it. You can flip it maybe so we want it to spin the other way. You can also change the play rate of the animation. And then next we have the kind of sorting layer here. And this is just going to be showing us whatever layer the sprite is going to render on. So earlier, kind of how I showed you when we were in the map settings, if it was on layer 2, that would change how it renders in front of or behind the player and other various different objects. For here, this is fine for now though on this NPC layer. And that's kind of everything for the sprite render. And then next up we have this trigger component. So this is what determines how we actually hit the player. So a trigger is this kind of imaginary box that we have where we say, okay, if the player is kind of in this range, then we're going to do something. That's kind of the basics of how we are going to set up the actual interaction when we tie it to the player. So we have this collider. This is currently set to be a box. You can also set it to other different things like a circle or a polygon with like different complex points. So maybe if you want it to be like go to here, to here, to here, to here, to here, to here, that's something that you can do as well. The easiest way to kind of edit the box is to click on this edit here, or if we really just want to do an auto, you can click apply and it will try its best to kind of auto fit it to this right here. I actually do prefer though to give a little bit of leniency to the player in games like this. And then another useful thing is if we have settings that we like about this, we can go ahead and kind of take those settings. So I want to copy this box size. I can actually copy and paste these individual kind of features here. So copying that, and then we could do the same for that. We could also go ahead and copy the component, and maybe I can remove this component, and then I could paste this component as well. So this is another way we could kind of apply these different settings. So I'm going to do that for this because I like this hitbox better. So that's just one way we can go ahead and quickly copy these settings across these different objects here. So the next thing that we're going to take a look at is this tween line component. So this is something that actually is moving the object across the map. So we'll kind of see here when we click play, it'll do this thing where it kind of scrolls all the way down the map. And that's because of this tween line component. So what this does is basically says we have two positions. We have one at the top and we have one at the bottom. And I want this to kind of slowly over time move from one point to the other. So here we have its current position, and then this y equals -10 is where we want it to move to. And this is relative. So this isn't like the global world coordinates. It's actually relative to where it currently is. And this one way is basically saying, hey, it's a one-way destination. That's all we want it to do for now. And there's other different settings here that you have. We'll take a look at this a little bit more in code, but for now, it's just gonna auto start too. So this is a setting that basically makes it so, okay, does it do this immediately when it starts the game? And as you saw, it just does. And also auto destroy. So once it reaches the end, you could choose to destroy the object. This could be useful for a lot of functionality. We would actually like to reuse this log, so we don't want to destroy it. And there's other different kinds of interpolation settings you can look at in the documentation for this. So now let's actually look into kind of making one of these from scratch really quick. So if I go ahead and I create a new entity, so it's going to be an empty entity, and I go ahead and we're going to add that sprite component like we talked about before. Oops. Sprite, and that sprite render component. And then we have that RUID from earlier, so we actually have to, let's go ahead and copy and paste it so we don't have to search for it again. And see, we kind of notice, okay, well this is a little bit wider, which is fine, but you can see here that this is actually scaled down slightly. So let's go ahead and do something similar. So I kind of want this to be scaled at 0.8. And so you'll see here, you don't have to do anything special for the animation to play by default. It will just automatically do that if the sprite loaded is an animation clip. Now that we have the sprite playing and exactly how we want, the next thing we have to go to is the trigger component. So if I go to the trigger component, you can see here, and then again, I'm going to adjust the box settings to how I like. So we can do that auto fit, but again, this seems a little ungenerous to the player. So I'm going to edit this. Let's make it kind of maybe something more like this. And finally, we're going to add that tween, so the tween line component. And then you'll see here, we can add a destination, and then we're going to make it relative -10. And then all the other things should be fine by default. They're roughly about the same as what they are. I think this has a higher duration, so let's maybe change this to a duration of 5 as well. And now if we click play, you'll see that it should function very similarly. So now let's take a look at how these logs interact in the code of our project and how these obstacles actually function as like a game mechanic. So we talked about setting up the trigger and setting up the sprite, how to make it look like a trap, but currently by default, it wouldn't actually do anything. So that's where we have these trigger events. So these are set up on the player. If you're not familiar with what an event is, it's basically this thing that triggers to the object. So let's say we have the trigger component on the player currently. That trigger component is sending an event to the player, in which all of the components can read that event when it's happening. And then here for that event, we're picking that up in this player coin rush component, which is added to the player when we start this game. So in that, we can kind of see, okay, we have these two different trigger events, and in there we have two different things that we want to happen. So first we're gonna look, okay, is this a coin rush coin? If so, right now we're not looking at the coins, we're looking at the traps. So if it is not a coin, alternatively, I think another way of doing this would be checking if it is specifically a trap. But for now, we're just looking at some simple logic here. We're going to pause the player, and there's a actual like pause player function. So this is basically just going to play a specific animation for the player, the alert, and then it's just going to disable the movement component temporarily. It's going to also play a little sound effect, play a little visual effect, and then eventually it is going to re-enable movement after a set period of time. So here we see we have the hit recovery time, and then we see here in that pause player, it is actually setting a timer. Timer service is very useful. Read the documentation for the timer service. This is like just a tool that lets you, after a certain amount of time, automatically do something. If you've coded on other platforms, you might have done the on update loop for checking time. For here, we can literally just set a timer, and then once that 1 second is over, then it will resume movement. So that's how we kind of actually set up the interaction, but now let's go into the code for the spawning of the obstacles. So here in this coin rush controller is where we hold a lot of the actual logic for this minigame. So assuming you have a party game world, maybe you want multiple different minigames. For this actual party game world, we have the spawn log component. This is going to be the main thing that's going to be called. And begin play, we're initializing these kind of two setup functions here. Initialize the log setup and then initialize the coin setup. For now, we're looking at the log setup. So if we go here, that's calling this function right here, the start log logic. Well, actually first it's calling initialize log. So here you'll see we have, this is basically just getting us all the different logs in the project. So here we have log 1, 2, and 3. This is just a quick little function that's going to go, hey, I want to add all of these entities, and it's looking for log I, which is going to be 1. It's going to check for 2, and then it's going to check for 3. And then it's going to add this to this little table for us just to make things nice and handy. And then we're going to go to the start log logic. So this is actually going to be triggered in this start game function here. So once the player has readied up, it's going to start that log logic. And then we go to the spawn log. So this is the kind of like core function here that kind of goes through the spawning of the different logs and all 3 of the different little locations. So the main thing here to take a look at, a lot of this can be kind of confusing to look at, is I just want you to see that it is selecting a random log, and then it is going to use that tween component, and it's going to reset the log. Walking step by step through this is a little bit daunting, so I recommend you just kind of look line by line. So here we're going to that log table, we're getting that first log position, we're enabling it. So this is if like we were looking at the first log, or we're doing the second log position, we're enabling it, and then we're playing the tween for both of these logs, and then it's moving from the top all the way to the bottom, and then we are going to set a timer so it'll actually disable the logs once it's finished its little animation. So that's just something we can take a look at, and then it does it again here for different special logs. Now you can customize this to be however you would like. You can set up your own different kind of log spawning patterns, or your own system that determines how the logs will spawn. But this is kind of what we're doing. We're just kind of playing it. We're starting the tweens, we're stopping them, and then we're resetting them. So now let's go ahead and take a look at how the coins work in our little mini game. So functionally, the coins work kind of identically to how these logs work, in the sense that we have that sprite render component, we have a trigger component. As they spawn in, the player touches them, and then that trigger component will activate. But what's special here is that we're actually using a model. So here we open up the model for the coin. What this is basically a preset. So here, like if I go back to the scene, you could create a model out of any of these, and it'd basically be this reusable thing that we could copy and paste and edit. And then once we make an adjustment to one, we could then apply those changes to all of the other instances of that model. So if I go to this model, we'll see here it has all these different settings. Obviously, we're not going to want to have to like recreate all of these settings and initialize those settings every time we want a coin. So we can kind of reuse this little coin template model. So here again, we have a sprite render component. We have a trigger component. And we also have this special coin rush coin thing. So this is basically saying, hey, is this coin still valid? What's the coin value? By default, it's going to be 10 on all these coins. So back when we were looking at the score earlier, that's going to be applied to the score. So each coin is worth 10. So if we got a score of 100, it would probably that you had 10 coins worth 10 coin value. And then we can also have a function to set the position of the coin, which is just going to be used by another code block, which is going to just basically use this to set the position of the coin whenever it needs to. And when it does that, it's also going to go ahead and enable the coin so it's valid for the player to pick up. And then once somebody gets the coin value, it's going to return that coin value, but it's also going to disable the coin. And that way we can just allow no other players to pick up that coin. So let's go ahead and go back to our coin rush controller. So again, this is controlling a lot of the logic for our world. So you'll see here, the logs, we're now initializing the coins. And then again, on the start game, we're initializing the coin spawns and we're reserving different spots. So here, we're just basically checking spawn coins in all these different positions. And then if we go back to that initialize coin here, we'll basically check if the coin model is valid. And then we're going to spawn the different coins. We're going to keep them disabled to start, but we're also going to add them to this table where we can kind of access all of the coins on our map. And then this is just going to check how many coins there are left on the map. And if it needs a respawn, it's going to check every so often and then respawn the coins. So here you can see we're using, again, the timer service to kind of do that process. And let's go ahead and look at the pickup logic. So again, if we go back to that player coin rush component, so this is the component that's added to the player, we have that event. Again, when we were looking at the logs, we saw there was another event here that's actually being triggered for the player when they hit a coin. So here we have, is a valid coin, is it actually hitting a coin or is it hitting something else? If it's hitting a coin, then we're going to get that coin component, and then we're going to add the coin to the player's current score. And then you'll see here that the score is actually kept under the player component, so it's kept per player. If you're doing this for a bigger multiplayer world, ideally you're going to want to keep track of this and kind of handle a lot of this logic on the server, and that way we can kind of keep our score safe. But for now, this is just a client-sided project, just looking at kind of how to set things generally. So that's it for kind of setting up the coin logic. Basically the essentials to get the coins working on your project and how we kind of implemented it in this template. The next thing we're going to take a look at is really quickly setting up the Ready Up UI. So first we're going to talk about how to generally set up UI. For this project, we have just a very basic kind of ready menu. So first let's go ahead and take a look at how we might make something like that. We can open up the UI tab, kind of like how we did the tile editor. UI and tiles actually have a lot in common. So we here have the UI groups as well, and these UI groups are basically like the layers for UI. UI goes in its own little special tab here, so we have our different layers set up here. So for the UI group, we can go ahead and click on these and you'll kind of see what they look like here, and you can edit each group individually. Again, same thing applies where different layers will have priority over other layers. Stuff like that, so keep that in mind. We're gonna go ahead and create a new layer just for setting up this little demonstration of how to make UI. So let's make this, for example, the begin ready UI. So as you saw, when the player clicks ready, the game starts. So how would we make something that kind of functions similarly? So here, we're gonna go ahead and create a new UI. So here I'm creating a image. So all I did here was I clicked this. You could also right click, create entity, and then click UI sprite. That would functionally do the same thing, just multiple ways of doing it. And again, this is a sprite GUI render component, which means it functions just a little bit differently. UI obviously is going to be shown on a screen separate from the map. So this is not going to move when the player moves around. This is going to stay in this position of the screen. So that's why we also have these different anchor presets. So I could anchor it to the bottom left corner. I could anchor it to the top right corner. And so whenever maybe the screen shifts, so maybe they're going from like vertical to horizontal, or they have different phone resolutions, stuff like that, this just knows where to be at on the screen position. And like I said, this functions a little bit differently, so we have a couple different properties here. The main thing that's important to know is that you can have UI also in the world as well. This is important for having like text and stuff, but in general, you're going to want to use the sprite GUI render component when you're working with UI, and you're going to want to use the general sprite render component when you're not working with UI. So here I can go ahead and I can select some good presets. Here are the ones like this. Let's try to find one that looks a little bit more visible. There we go, perfect. So what you'll see here is this is one of the key differences with this GUI render component. We have these options for like slice. What this is basically doing is it's saying, hey, keep the corners intact along the sides and in the center. I'm going to actually stretch out those lines. It's kind of a different way of handling images, because when we stretch this out, we don't want like the whole thing to be stretched out. We kind of want the patterns in the middle to be repeated, and for these lines to be repeated in the right direction. That way we don't just get this one really big blurry thing. So this slice feature is really important. You can also select to fill the center or not. So here you'll see it's not filling the center of that image after it sliced it and kind of tiled it. But we do want it filled in the center, so filled there. And then let's put this at kind of the bottom of our screen. And then that's kind of the start of our UI. There's a couple different things here. So if I go to the UI group, we see here default show. This is really important. So do we want the UI to show by default at the start of the game? By default, this is actually off, but we could turn that on just so it shows when we click play. And then I think we will just go ahead and keep that on for now. And I want this anchored to the bottom left corner. So that's just where I'm gonna put this for now. And then let's go ahead and turn that on. Again, you can have the UI transform pivot points for the whole group as well. This one means it's stretching, so it's going to dynamically change the ratio of the whole screen. So that could be useful if whenever you make an entity and the screen size changes, it's going to stretch along with that screen size. The next thing we're going to do is add a button. So that ready button was of course a button, and there is interactions with that button. So let's go ahead, add a button component. And so here we'll see we can change a couple of different options here. By default, all we really need to do is add the button component. We can do a couple of other things like a color tint. So what this does is like this transition type. So if I were to interact with the button, like let's say click it for example, it would actually change the color. So I have this press color, the normal color, which is like the generic white, but maybe the press color, maybe I make it like red or something. So if I click play, and we will ignore all the other UI on the screen, you'll see that it actually turns a reddish color. We also have the option here selected when I'm hovering over it, and then again, normal color. There's also a highlighted color. This is probably not going to be relevant for most projects, but you can kind of take a look at how that works as well. And then the fade duration is just like saying how long is that transition time going to be for the switches between the colors. So now we're going to take a look at how to actually set up the button and tie it to logic. So there's a bunch of different timer logic here in this timer UI controller function. So you can take a look at all that if you would like. But for now, we're just going to be focusing on this property entity start button. So here we are actually getting the UI that we created earlier. We're actually going to be using the templates UI, but functionally it's the same as what we currently have right now. And then here we're going to tie that. So here we're creating a new handle button click event, but we're not listening this time to our own object. We're actually listening to the start button, and we're listening for that button click event. And then whenever we see that event, all we're doing is we're setting the start button to false, and then we are starting all of the timer logic. Now, however you decide to set up the timer logic in your own world could depend on how you want your game to function. Here, it's basically just setting the timer, displaying the timer to count down from, I believe, 60 seconds, and just slowly increment down. Yeah, so here you can see 60 seconds, but it might be different for everybody's world. It's also going to get that text component, so the timer text here. So if we search timer text, we can see here every time it is updated. So here it's going to be updated self.timer text equals, this is actually setting the initial text component. Then if we go down to here it's actually going to format on update what the current time left is. So here it says if the timer logic is running, then kind of update this to be whatever that timer logic is. And then here, this is going to be in that timer logic, and this is also going to show all of the different functionality for how we set up timers. But again, we're not focusing on the timers for now. For now, we're just focusing on the UI, and that is how we tied the button event. Now, additionally, there are a couple of other different things that we have. So we could create the UI for the timer. So here, that's what this looks like. Now, this is essentially the same thing, but without the button component. And it also additionally has the timer text, which is just this text component. So again, we have the text GUI renderer component, which functionally works kind of like a sprite renderer component, except we're taking text as an input. We can also have fonts as well. And then we can have a bunch of different, like, your typical paragraphing options. So your font size, your font color, other different things like the padding, the outline color, and stuff like that all goes here. And this is what is being updated in our code. There isn't much UI else for this project. It has fairly simple UI. That's all you should really need to know to set up the essentials. But again, if you have any questions, please let us know in the comments. So finally, for our last portion, we're going to be talking about data saving. Now, this is something that we're going to be looking at exclusively in code for now. So it's important to note that MapleStory Worlds actually will hold all of your data for you. You do not need to do anything or host your own data platform. We will keep all of the player information that you need. You just have to set up a few different things in your code. So here we're using this data storage service. So this is the service that you're going to be calling when you need to access data storage. And then we have the get user data storage. So I want to clarify which data I want to access. And so for this one, we are currently getting the user data. So for which user? Well, the user ID of the player. So we're getting the score is what we're currently loading. So now that we got the data storage for the player, we want to actually get and weight a more specific category. So for this, we want to get the server best score for the player. Basically, we can kind of categorize it as we have the data storage, then we have the data storage per the user, and then per the user, we have the data storage for the server best score. So we're kind of narrowing down the different stuff. And again, I recommend that you look at the data storage service documentation. There are multiple other kinds of data storage as well. You can have data storage per creator, per world, and then a couple of other different options that are just a little bit more flexible for your different needs. So here we're checking, okay, did we successfully get that data? Is it real? Sometimes there might be like an error trying to get the data storage. Maybe like your internet goes down for the player or whatever happens. We're just checking if none. And then we can actually add logic for if it fails. But for now, we're just checking if it succeeds. If it does succeed, we're going to update that best score. So here self.serverbestScore. And then we're gonna equal to number the value of whatever the client's current score is. So that's all that really needs to be done. So we got, get and weight, and then we're setting that best score. So this is the loading of the score. But now what if we want to actually change the value of the score? So here we have the save score function. So again, we are going to be getting the data storage for the player. And then we'll see I've added this line of code here, storage, set and weight. So the server best score is what we want to save. So we can see here, it's the same category. And set and weight, there's different ways we can set it asynchronously, which means we don't really care about the execution order of the code. We just want it to function. And then maybe we have a function that's called once it's done, but set and weight will pause the execution of everything else in this component, or this specifically this call stack, until it is finished completing. So we have set and weight, and then we are just setting this as a string because strings are just generally kind of easier to keep track of, and we are saving that data. There's also a couple of other functions here. So we're kind of requesting to save. This is an example of kind of that client and server communication. You can only save data on the server. You can't save it from the client. So the client is actually going to have to request to the server to actually save that data. That's pretty simple. Again, I recommend you really check out the client and server video coming to the platform if it's not out already, because that will kind of cover the different essentials for how this communication works. Thank you all for watching. If you guys have any further questions, please feel free to let us know. Additionally, there are the links to the remake world in the description where you can clone this project. You can take a look, you can read through all the scripts. And then again, I really recommend if you kind of struggled with any of the initial concepts in this video, that you check out the Pro Mode series to really get started. And then also take a look at the other sample projects that we have. Thanks for watching.